Is it- are we live?
I believe we are.
Hey, hey everyone. Nice to have everyone here. Um, uh, awesome. Let's get started. This Google Cloud workshop is starting. Make sure to sign in at that link. HTTP colon slash bit.ly Cloud Hero RSVP. Um, uh, Hopefully, if someone could put it in the chat, that would be great. Um, yeah, let me go ahead and yeah. So, welcome everyone to the Cloud Hero. Welcome to Cloud Hero with data at ML with BigQuery. Um, my name is Azar Ali. I am the developer student club lead at Florida International University. After the workshop, we'll be answering any questions on how to become involved with our university chapter of Developer Student Club. And furthermore, I would like to introduce the Googlers that will be leading this workshop today. So please help me welcome Ryan Matsumoto and Gustavo Rincon.
Hey everyone, I'm Ryan. I'm a developer advocate at Google, based in the San Francisco office in California. And welcome to Cloud Hero. We're super excited to introduce you to Google Cloud and all the amazing things you can do with our products.
Hello everyone, my name is Gustavo and I'm a cloud customer engineer with Google based out of South Florida. I work supporting some of our largest customers here in South Florida, and happy to be here.
Awesome. Yes, so let's get right into it. So here's what we're going to be doing today. We're going to learn, well, first, we're going to learn more about the game itself and why we're playing. We'll hear from Ryan and Gustavo next about some relevant solutions, about what the possibilities are in using them. And then we'll move on to how to play and getting set up for the first lab. After we have created a quick labs account, we will enter the campaign code and then let the games begin. We'll then close out the workshop with some pro tips that will assist you in completing the other labs and have a quick Q&A. So what is cloud? Well, cloud computing can be a confusing term, but at the most basic level, it means that we're getting things done using someone else's computers. The definition that you read here is, of course, not cloud computing. It's a different type of cloud, but the Google Cloud Platform allows us to use Google's computing infrastructure to help us run applications that we're building. So what exactly is Google Cloud? Well, Google Cloud is a suite of secure storage, innovative ML, powerful compute, and integrated data analytics products and services. So how do you build skills to get the most out of these technologies? Well, you have to take a new approach. Equipping your team with the right skills can make or break your journey into the cloud. Traditionally, IT training has been largely centered around one piece of technology, but cloud technology requires a new way of learning. It's no longer just about learning and operating the technology. It requires a change in mindset. Google Cloud Training helps you understand how to use the technology within a job function to build cloud solutions that drive cross-functional successes. We have role-based learning to help your team thrive in the cloud-first world and help them move from maintainers to strategists, innovators, and become disruptors. So that brings us to one of our first questions. What exactly is Cloud Hero? What are we here for today? Well, Cloud Hero is a virtual hands-on training event using the game functionality on Quick Labs to help technical practitioners gain skills through interactive learning in a fun and competitive environment. Cloud Hero brings developers together to compete against one another in gamified labs by using their Google Cloud skills. It's one of the many interactive products from the Higher Education Learning Center from Google Cloud. Overall, it's one of the many steps towards the path of gaining some perks and certifications. So here's an overview of the labs that are included in the data ML data and ML with BigQuery. Today's workshop will be first starting to focus on BigQuery, quick start command line. Then we'll get into getting started with BQML, and we'll also cover weather data in BigQuery. Each labs are building blocks, and they build one another. So if you start with BigQuery, it'll help with getting started with BQML, and that will help with weather data in BigQuery. So they build upon one another. So there are several ways to keep learning after this event, past us teaching you how Cloud Hero works. And the URL that you need to know and to visit is g.co/learncloud/programs, and you can learn a lot more there. So this workshop is the Cloud Hero workshop, as we know. And participating in workshops like Cloud Hero, along with other labs and the Learning Center from Google Cloud, can help individuals from any field, including technical practitioners, researchers, and students, to begin their collection of skill badges. These are skills that you can use for any sort of personal and professional projects. They can also help you with your job search and make you a marketable candidate. So I'm sure everyone's wondering, what are skill badges? Well, skill badges are gained by completing a series of hands-on labs, including a final assessment challenge lab, to test your skills and earn a Google Cloud skill badge to share with your network, such as like LinkedIn or some other source. A challenge lab is a scenario-based lab where you have to take the steps to complete the task. There are no instructions. You rely on what you've previously learned before. So here is a brief overview of the multiple skill badges you can potentially learn. This Cloud Hero will be step 1 of the Data, Machine Learning, and AI badge. And completing the 3 remaining labs and the game, from what I first covered, they will help you gain a Cloud Hero skill badge that starts you on your path. And as I like to say, you got to catch them all. You got to get through all of them. So it's very exciting. So why exactly are collecting skill badges so important? Well, skill badges help you all practice and training for the Associate Cloud Engineer certification. How cool is that? I mean, earning credentials like these are a great way to show potential employers what you know and what you can do. So this is amazing. And now I'll be handing the mic over to Ryan and Gustavo, who will talk about data and ML.
Awesome. Thanks so much, Azar. So let's talk a bit about data and machine learning on Google Cloud. So let's consider an example problem of distinguishing between photos of puppies and photos of muffins. So this is an image classification problem. And one really simple way to go about this would be to hard code a very simple rule where we check to see if there are eyes in the photo. And if there are eyes, we'll say it's a puppy. And if there are no eyes, we'll call it a muffin. But sometimes it's not going to be so easy. So now the rule of looking for eyes doesn't work because the blueberry muffins have blueberries which look like eyes. So this shows us that that process of using hard-coded rules only goes so far in solving this image classification problem. Another example problem is this sentence. The brown quick fox jumps over the lazy dog. So one thing that's special about this sentence is that it contains every single letter of the alphabet from A to Z. But you might have also noticed that there's something wrong about this sentence, and that's that it should actually be the quick brown fox instead of the brown quick fox. And it might be hard for you to sort of articulate why that's the case, but the reason for that is that we have these syntax rules for adjective order in English. So with multiple adjectives in a sentence, they need to be in the following order. And what's interesting here is that chances are that you wouldn't be able to explicitly say what these rules are from the top of your head. Instead, what's going on is that you sort of know these rules automatically, and you sort of subconsciously know them. And the question is, how do you learn these rules? And the answer is that you learn them through experience. So by observing how sentences are structured, by reading books, by hearing people talk, eventually you pick up on these patterns over time for how these adjectives are ordered. And then eventually you just sort of know what sounds right and what sounds wrong. So that's very similar to what happens with machine learning. So machine learning is learning from rules plus experience. So the experience part is super important, where we continually make our machine learning model better over time by observing new pieces of data. So here's a nice diagram showing how machine learning differs from classical programming. So with classical programming, you take data and rules as the input, and the output is the answers. But with machine learning, it's a little bit different, where your input is actually the data and the answers for that data. And you sort of work backwards to figure out what the rules are. And then you can apply those rules to new pieces of data. So basically, you can use past data and learn patterns from it that help you evaluate new pieces of data. So a few different definitions of machine learning. One of them from the IEEE organization says that machine learning is the study of computer algorithms that improve automatically through experience. Another definition from one of our colleagues at Google is that machine learning is using data to answer questions. So generally with machine learning, there are three different phases: data collection, model generation, and prediction. And as our model takes in more data over time, it can generate more accurate predictions for the question we're trying to solve. So machine learning teaches a computer to make repeated decisions using standard algorithms and lots of data. And the data really is the key here, because we use that data to improve our machine learning model. So machine learning is used a lot at Google for different Google products. So one example is with the Google Photos app. So one of my favorite features of it is the keyword search, where you can search for all the photos in your collection that are photos of dogs, and then all these dog photos will show up. So what's happening here is that Google Photos is using machine learning and vision technology to detect whether or not there is a dog in each photo. So the owner of these photos never had to manually tag these photos as dog photos. Google Photos is automatically detecting that using ML. So the key here is that Google trains its machine learning models on billions and billions of images to generate an accurate predictive model to label images. Another example of machine learning at work at Google is with Gmail Smart Reply. So you might have noticed that when you get an incoming email, it will give you a few different suggestions of how you might want to reply to that email. So this is done using machine learning, using natural language processing technology. So AI and machine learning is obviously very powerful. You can do a lot of stuff with it. But one of the challenges is that it can be really difficult to get started with machine learning. And very few people actually have the skill set necessary to create these custom ML models. So one of Google Cloud's main goals is to empower more users and more developers to use artificial intelligence in their applications, even if they don't know all that much about machine learning yet. So one of our main goals is to democratize AI by making it easy, fast, and useful for all developers and all users. So one product in particular that we're going to focus on today is BigQuery. So this is Google Cloud's big data database. So BigQuery lets you store and retrieve large data sets. And you can query these BigQuery data sets using mostly standard SQL syntax. There are a few small differences, but you can look up some of those in our documentation. So BigQuery also has a lot of really great free public data sets that are available that you can query for free. So these include COVID-19 data sets, such as case counts, mobility data sets, demographic data sets, and economic data sets. There's also things like NCAA basketball data sets to get data about past tournaments and games. And also different city-specific data sets. So there are data sets for the city of Seattle, Los Angeles, Chicago, New York City, and a whole lot more. So a lot of really great free public data sets that you can explore using BigQuery. And BigQuery is accessible in a few different ways. So one of them is via the Google Cloud Console. That's the web portal where you can manage your cloud resources directly from your browser window. And also, you can access BigQuery via code using our client libraries. So let's go ahead and get started with our first interactive hands-on lab with BigQuery. And Azar is going to walk you through that right now. Well, actually, sorry, I missed one thing. I forgot about this, but we have this video about how students in LA use machine learning to identify potholes. So let's watch this first.
And I'm Erickson.
And we're using machine learning to find potholes on the streets of Los Angeles.
LA has over 7,400 miles of roads and freeways.
That's a lot of roads and a lot of potholes to fix.
Right now, construction workers have to manually inspect roads for dangerous potholes and cracks, or rely on people calling in tips, which takes a lot of time.
While studying at LMU, we started to see if we could figure out a faster way to identify potholes throughout the city.
First, we needed data. So we rigged a camera to a car, and we drove around to capture footage of different roads and freeways.
Then, we used TensorFlow, Google's open-source machine learning tool, to develop a model that could quickly identify potholes, road cracks, and other weird stuff with a high rate of accuracy. Which means workers can spend less time finding potholes and more time fixing them.
So a lot of great things you can do with some of the different Google Cloud big data and machine learning tools. And we're going to help you get started. So Azar is going to help walk you through the first quick lab, hands-on lab for getting started with our BigQuery big data database.
Hey everyone, I'm back. So yeah, let's get started on with the Cloud Hero. So just a reiteration of what we are going to be doing. So we'll be going over on how you actually you play a Cloud Hero, and we'll go through the first labs and the second lab, and we'll have a workshop wrap up, and we'll do a discussion in the end. So okay, now let's get started. For the Cloud Hero, we're going to use an incognito window. Why are we doing this? It's because that way, when we start using the assigned credentials, you'll find that everything goes way more smoothly. And by the way, Chrome browser works best for Quick Labs and Firefox next, although you can use any browser for the Quick Labs. But I recommend Google Chrome for this event. So next, please sign in to Quick Labs if you already have an account, or you can join. This is our hands-on learning environment where we actually really get to be live in the Google Cloud Platform's ecosystem. So we'll give everyone a few minutes just to start getting set up with their accounts. And yes, make sure that you're using an incognito window. You can click join to create a new account or sign in. Okay. Okay, I'll go on with next. So here's how you could change the language. You take the labs in if you like. You can select your profile icon on the top right-hand corner. You can go to My Account. Then in the left menu panel, you select your profile information. You scroll down and you click the language field. Select your preferred language. And then you finish up by clicking on the Update User button on the bottom. I think by default it should be on English, but if you prefer to do the Quick Labs in a different language, that's how you could do it. And then yes, so here's also if you want to change your name on how your name shows up on the leaderboards. This is how you can present your name as well. So you stay on the profile info page that you were previously just on. You click into the player name text field, and then you enter your preferred player name. Just a quick note that inappropriate names will get banned from the game. Please pick a family-friendly player name, and that'll help us also know who the winners are. I suggest just putting your first and last name, typically. And then you could finish up by clicking on the Update User button on the bottom. So here is the game link and access code. This is the campaign access code that we will be using today. And google.quicklabs.com/games. Make sure. Okay, yeah. So this is the game link, google.quicklabs.com/games/1262, and then this is the this is the access code on the pop-up window. And then once you have entered the access code, you'll be granted access to the 4 labs and the actual game itself. So next. So this is what you should see, for example. This will be the, yes. Let me go ahead and share my screen on Quick Labs. Give me a second, please. Okay. Let me one second. Okay. Wait, can everyone see my screen here? Let me go ahead. Okay, cool. So we'll get started on with Quick Labs. Incognito window. Okay. So I'm going to stop sharing the screen, and I'm actually going to start going through with the actual process on how the Quick Labs will work. So I'm going to stop sharing screen, and then I will be I will share the screen with everyone. Give me a second. This is the incognito. Okay. Okay. Let me. Okay. This is what we're going to do. My apologies, everyone. I will stop sharing the screen, and then I will share back this other screen that I have here. Okay. Sorry for those technical difficulties, everyone. But these are the access codes that we will have access to. So here, for my personal game, this is what I'll be using for the game. So I'm just copy that. And then this is the code as well. So then, so here we go. Next. And this is what you should typically see. This should be your front page, Cloud Hero, University Data and ML. So that's when you log in. And this game has 4 labs, and I will be going through the first one with you, everyone together. And you'll see the 4 different labs down there. BigQuery, Quick Start, and Command Line is the one we'll be doing. For each lab, please remember to use the new username, password, and project ID that Quick Labs assigns you. Okay. And then you could choose one of the labs to start, and make sure to press End Lab once you're done with the lab. So then I will start going through the first lab on my end. Yeah, let's get started. Okay. Okay. So if everyone can, oh, wait, don't. Sorry. I'm going to be sharing just this tab I have here. Cool. So this is what we'll be going through. So first of all, we'll be going through the Quick Labs game. So we'll copy the Quick Labs that I shared with everyone earlier, which is going to be this. You could sign in using your Google account. So that's what I will do here. Put in my Panther information. Okay, then you will be presented with the University Data and ML with BigQuery. And then you'll see the screen here, and you will be allowed to quick join the game. So this is where you could click next. You'll see that the game is private, so you'll need to access a code. So for our purposes, that is 2F educr-shell, or 2F, I'm sorry, -educr-shell. So you put that in, and then you should be good to go with University and Data ML. Wait, what? Oh wait, you can't see what I'm doing. I might be. My apologies. I might have been sharing the wrong. My apologies, everyone. Can I saw the space background? Okay. Awesome. So let me. So apparently, I was not sharing the correct screen. So let me just quickly redo what I just did. It was just logging in to the system. So you sign in. Well, with the code that we have, you use the Google Quick Labs link. You sign in. You access a specific game, sign in with Google, and then I logged in already. So that's just how you log in. And then I entered the code that was on the screen. So that is how you go through with it. Next, what you want to do is you want to click here on Cloud Hero Data and ML with BigQuery. And then you want to start with the command line, which is the first lab that we're going to be doing. So you'll see here that you have an overview and you have how to exactly be doing the lab. And if you're doing this on your own, then these are the instructions that you need to be going through. But for the purposes of this lab, we will be going through these together. So first of all, so you have your setup. So you will have, so this is how you actually start up your lab. You will be given, so first you start the lab, and I'll give you like this page here where you can open the Google console. You'll be given a username and a password and a group project ID. And with this information, it allows for you to log into the Google Cloud system and with the credits that are on that account. So we will start the lab. Last time I checked, I was not a robot. Yep, and then we see that. Okay, so that's how you start the lab, and then okay. So what you need to do next, you have the panel with the credentials. You copy the username, and you actually want to go into the Google console so you can log in. You can log in using your email that they provide you there. And you're also given a password, so you copy that information in there. Accept the terms, of course. Confirm. Yeah, it takes a second to load. Okay, awesome. So we're now in the Google Cloud Platform. We want to agree to the terms of service. Next. Awesome. So we are now with the account now, and we're also so we're logged in. Next, what we want to do is that, so once we have accepted the terms of conditions, we want to open the Google console, and then you'll be able to see everything that you are able to see that everything that Google Cloud Platform has to offer. And as you could see, just me scrolling through, that it's quite a lot of stuff. So, and there's so much that you're able to do with it. But for our purposes, we're working with the command line. So that means we need to activate the Cloud Shell. So the Cloud Shell allows for us to, it runs its own directory, and it gives us access, command line access to the Google Cloud resources, such as BigQuery, for instance. So in the Cloud Console, we'll be activating the shell. But if you go on here on the top right, you're able to activate it, and it'll pop up on the bottom, just like so. Awesome. You guys are just doing a quick check. Okay, awesome. So you see the terminal on the bottom. That happens there. So now that we are in the console, we want to connect with our actual environment that we're working in, since we're starting from a fresh, clean slate. So when you're connected, you're authenticated like so. So you can actually list the active account that's being used, which is that we are using, by using gcloud auth list, which is the authorized list in Google Cloud. You can paste that in, and then it's requesting to make an API call, authorize, and it'll actually give you the account that is currently being used, which is student, the email that we put in from over here, actually. So that's what that is. And yeah, that's what the actual credits are. You can list the actual project ID that we have working here with this command as well. So let's copy that. And it will tell you Quick Labs GCP 206, the same exact over here. So that is telling you what the actual project ID that we're currently working with is. So, and that is just how to get set up. Now we want to actually start examining tables, and actually using the BigQuery that GCP offers. BigQuery offers a bunch of sample tables that we could test queries on. For this lab, we'll be using the Shakespeare table, which contains an entry for every single word in every play, which is pretty cool. So let's do an example here. So we have here this command, BQ. BQ is BigQuery. Show is to list out everything that we are, what we are querying from. Then we have BigQuery public data sample Shakespeare. So this is the actual data table that we have that we want to show. This is the actual data set. So yeah, just like we said there, this is the name of the project. So we'll put that into our command line. Let me make this a bit bigger so you guys can easily see it too. Here we go. Awesome. So we actually see that there are 164,000 different rows and how much memory it takes up. So there are actually about 164,000 different words that the Shakespeare database keeps a track of, which is quite a lot. Next, and then that's how it shows up as well. So next we want to run the help command. And if you have a specific, like you want to run a specific command, but you're not sure how it will work, BQ help retrieves information about like a specific command that you want to use. So if you want to know how to use the query command, you can use BQ help query. So then it gives you all the information on about the query command right here. And all of the different, so if you want to cluster fields, if you want to filter through your results, like max statements, it allows you to do all of that. And you're also able just to do BQ help, which allows you to list all of the commands as well, which are everything here. If you want to extract, if you want to insert into a table, ls, like list everything that is in the system, you're able to do that. It works like just like another. It has some of the same commands as if you were using a normal terminal. So now we want to run a query to see how many times the substring raisin appears in Shakespeare's words. And to run a query, we're actually able to run a specific command using actual SQL code. So the query that we have here is this one on the bottom, where we're able to select the word, the specific word, and then from this data set, from BigQuery public data, samples data set, and then where the actual word is raisin, and then it groups all of those words. So we can go in to our system, and it's running into the system now. And yeah, so we see here, not exactly the word raisin shows up, but we see words that contain the word raisin in there, like praising, raising, dispraising. And then also there was one play where they said raisins, but not the actual word raisin. So that's pretty interesting. And then in this command, we are able to make SQL the default query syntax, which is what we used up here. Okay, now that we completed this task, we want to check our progress, which goes into the system and allows for us to check what we're doing. Yep, so it verified that. So yeah, next here, if you search, so let's do a command where it actually doesn't, what we won't get any results. So if we do the same command like huzzah, then like what they do here, and you actually, so yeah, nothing happened because there aren't actually any results. So nothing was listed, which is exactly what we wanted. We'll check our progress here. And we got verified. Cool. So that is querying data. Now, if we want to actually use the information and create tables, we are able to do that in the system as well. So if we want to create a new data set, where a data set is a group of resources such as tables and views, sort of what we saw here, where this is a data set and in itself is a specific query data set with the word raisin. Well, we can actually make our own data sets. So if we want to check what we already have, we do BigQuery ls, which is listing the directories. So we'll put that there. I'll type in qls. Cool. course, we don't get back anything because we actually never added any data sets to the system, to our data project. So there aren't any data sets. Yep. So if we run BQLS and the BigQuery public data project ID, it'll list all the data sets in that specific project. So we this BQLS was just for our project, but we're able to also list out for other projects as well. So we can go there and we could test that BQLS actually does work. Yeah. So you'll see all of the different data sets that actually exist. And there's so many different ones that exist. COVID-19 from Italy, Chicago crime, baseball. Yeah, there is so much here. And this isn't even all of them. These are just the start. So that's really cool. So now that we are able, we show that we're able to like list out our directories, let's go ahead and make our own directory so that we could have it in our system. For this project, we're going to make a new Quick Labs project, or we're going to create a new data set called baby names. So we're going to go here. And we see that baby names was successfully created. So we have that in our project now. Let's check our progress real quick. Cool. So now we want to run BQLS to perfectly make sure that baby names actually does exist in our terminal or in our project. Yep. There we go. Dataset ID, baby names exists. So BQLS does work. Now that we have this empty data set now called baby names, we actually want to upload the data to the project. So we're going to import a custom data file, and it's approximately 7 megabytes, so quite a bit of baby names, about popular baby names provided by the Social Security Administration. So we don't have to download the file like directly, click into it and all that. We could run this command where we get the actual link and it'll put it, we're able to get it to our project. So cool beans. So we have names in our project now that we want to list the file and make sure it's in our system. So ls. There we go. So we see that names.zip is in our directory, but this is a zip file, and we can't work with the zip files because we would have restricted access. So we need to unzip the file in order to actually be able to use the file. So let's go ahead and unzip it. The command is unzip names.zip. So pretty straightforward. And you'll see all of these texts, which are actually baby names. Yeah, would you call it like text files? So these all have like different baby names, which is pretty big. So we want to just make sure, go back, list them all out. Awesome. So you'll see here that it's not only just in one single column. It shows up in many different columns, all of it, so it's a lot easier to read, and you're actually able to this makes sure too that you have all of the text files in your project. So now we want to upload all of these tables just using one single step, and the way how we do that is we do that using BQ load. And the arguments that we'll be using for our load command will be, the name we want to upload is the baby names. The name of the table ID we specifically want to get is names 2010. The text being yob2010.txt, which you can actually find here This is just one of our text files in our in the file that we downloaded. And our schema is, what we're actually getting. So we're getting, the name is a string, the gender is a string, and the count, the amount of baby names, it will be an integer. So we can create our table using this specific, loading what we specifically want using this command, is bq load. So that was that's the actual argument. Baby names.2010, and then the actual text name file, and then the name. So those are the arguments that you use. You're able to then go through and load them up. Awesome, that is done. So we've created our table. We've loaded everything there. Check my progress. Okay, now we've done that, we want to confirm that everything does appear. So we want to do BQ ls baby names. And what do you know? It shows up. What? Move. Shoot. Okay. Names 2010, it shows up as a table that we have. And if you actually want to see the actual schema of, generally what it should look like, you can use this command bq show. And show is just allows you to view a table that you're working with. Cool. So we're able to see that the table is comprised of name of these parameters: name string, gender string, count integer, and all of the rows and the amount of memory it's taking up. So now, if you actually want to run queries on this data set that you have made and actually get information from it, you're perfectly able to do that. You can get some interesting results based on whatever you want to query. So you can run this command to return the 5 most popular girls' names if that is something you're interested in based on the data set that we have. And how it works is, so it's BQ query. So query is always used when you want to get a specific source of information from your table. So you're grabbing it. Select. So this works also with SQL, where you select the name and the count. So this is, the name is the girl's name, and the count is the amount that'll pop up. It'll come from the baby names data set, the 2010, which is what we uploaded, where the gender is female. So that is the conditional that, if we didn't add that, it will return both. It will return everything, both boys and girls' names. So if we're starting to conditionalize it by putting in female, then we order by this count, where the limit, so we want to limit to 5 names only in descending order. So that means it'll run from, the most popular down. That is the descending order. So let's go and test this out. Yep, and there we get it. So we see that Isabella is the most popular name in the United States, followed by Sophia, Emma, Olivia, and Ava, which is really cool. I never knew that before. I was always wondered about that. But if you want to get some wacky information too, like the top 5 most unusual boys' names, you're totally able to do that too. So the query for that is you select the name again and the count, so the amount of names that you want to get, or no, I'm sorry, it returns the actual amount of boys that had that name from the data set where the gender is male. And instead of descending, it puts it in ascending order. So you'll get the least. It will go from least to, least to most. So, and if you limit by 5, then you'll only see the 5 least popular, with the top one being the least popular. So let's go ahead and do that. Cool. We see this now. So the least popular is Akib, followed by Aiden, Adharan, Arian, and Amarion. Interesting. So those are some different queries that you're able to do based on the data set that we built. yeah, and that's essentials of how you are able to use the big data BigQuery to access information. Now let's test and see if we were able to understand what we just learned. How can you access BigQuery? I believe, well, we were definitely using the command line tool, so we can use that. I believe we're able to use the Google library as well to access, and you're able to use the web UI. Hope I get this right. Oh, man. I kind of have forgotten at the moment the answer. We'll get back to that. But which CLI tool is used to interact with the BigQuery service? Well, obviously, we were using BQ to actually access those databases and use their commands, so it should be BQ. Yeah, that works. Okay, so now that we have done what we needed to do in the data set, we can run the BQRM command to remove all the baby names from the data set. So just to clean everything up. Yes. Okay, then it should be removed. So let's check my progress, see what I've done. Awesome. And that's it. We're able to use the command line with BigQuery to now manipulate data from different data sets that exist in BigQuery. So now that we have done, we have finished the quest, and which was what we just did, BigQuery command line. This is a part of a series called Quick Lab Starts. So you're able to learn the essentials of Google Cloud using these sorts of labs. And you're actually, by completing more and more of the labs that we're going to go over tonight as well, you were able to get certified. So to end it, I'm going to end the lab. And yeah, that's it. So what I'm going to do now, I'm going to stop sharing my screen, and then I will pass it over to Gustavo and Ryan to handle to go over the other. Let me erase your screen. Okay.
All right, Oscar, thank you.
Awesome. Yes, thank you. Thank you so much.
You were doing a quick biolab?
I'm sorry?
We're taking a quick break, right?
Yeah, I think we'll do the break, and if anyone has any questions, we can answer them now. But yeah, don't go anywhere if you're watching. We're just getting started. We have 2 more labs, and we have our expert, Gustavo, who will be walking through those labs. So definitely don't want to miss that. Let's see, any questions anyone has?
Oh, I see. It was REST API, CLI, and Web UI. My brain.
Oh yeah, the quiz questions. The cool thing with the quiz questions is that even if you get them wrong, you can try them over and over again, and eventually you'll get it right. It might take a while since there are 5 options and like a whole bunch of different combinations you can try. That's an interesting question. How many different combinations of answers are there for that? Yeah, just keep trying and eventually you'll get it. So someone asks, how long is the event? So yeah, I guess it sort of depends on how fast these next 2 labs go. So this Cloud Hero quest essentially has 4 labs. So we just did the first lab, the quick start one. And then the next 2 labs are similar to the first one. Gustavo will be walking through those. So that's getting started with BQML. So that's using BigQuery for machine learning. And then there's also weather data in BigQuery. And then after those 2 labs, then the last lab is actually the challenge lab. And the challenge lab has fewer, I guess, like direct instructions for like every single command that you have to put in. And you have to figure out a bit more of how to do it yourself. So that's why it's a bit more challenging. And for that one, you'll be doing that more on your own. But we'll be here to help answer questions as you go through that one if you have any issues as you're going along. So I would say like for those like next 2 labs that Gustavo is going to run through, probably like another hour or so. Okay, so Prakarsh asks how to start in ML being a sophomore and having knowledge of basic C, C++, data structures, and Postgres. Anyone want to take this one?
So I think lab 2 and lab 3, you'll have a chance to start building some models. Actually, lab number 2 is where you start building models on BigQuery, Prakash. So that's one good way to learn how to do that, just using SQL code within the SQL editor in BigQuery. I did post in the live chat a link to one of our crash courses on ML. That one's a little bit more advanced. It uses some TensorFlow libraries, but it has some really good content just to get started with machine learning and understanding the most general concepts first.
Yeah, so those next 2 labs will definitely be good for some machine learning stuff. We also have on Saturday, we have another Google Cloud Tech Talk focused on some of our ML products, where we'll talk a bit about some of our machine learning APIs and also Google Cloud Auto ML, both of which are pretty beginner friendly if you want to get your feet wet with some machine learning, but if you don't know too much yourself yet. And that one, I think, is at 1 p.m. Eastern time. And one of our colleagues, Alfonso, will be doing that talk. So definitely tune in for that on Saturday. Cool. So I actually have to hop off for a bit. I have another meeting to go to, but I'll try and come back at the tail end of that, depending on how long that lasts, and maybe help you with the last couple of labs. But yeah, definitely stay here. Gustavo will be walking through those next 2 labs very short.
Thank you, Ryan. Good luck.
Yeah.
Okay, so I think we could probably get started now on that second lab. So if you go back to Quick Labs, you'll see the next lab in the list is getting started with BigQuery ML. So I'll give everyone a minute or a quick second to get there. We're going to go through all the steps as well in this one. The only difference is I'm not going to use the incognito tab because I have access to the Cloud Console through my account. But for those of you who are on, just follow the same steps that we did for that first lab. And I'm going to go through them real quick again, just to make sure we're all on the same page. Obviously, just make sure you use the chat if you have any questions. All right, so how do we get started with this one? The overview here at a high level, we're going to be leveraging BigQuery ML to build a machine learning model to do inference. Basically, we're doing a logistic regression algorithm to determine whether a customer is going to make a purchase or not. So the only 2 possible outcomes here are yes or no. That's why it's a logistic regression model. Again, we're going to stay using Chrome or Firefox. You've already gone through this once, but let's just go over it again. As we recommended, please use a incognito tab for Chrome to log into Quick Labs. Once you're ready, you start the lab. And then the first thing you're going to do is you're going to click on the Open Google Console button that's going to show up here on the left. You're going to copy that username and password to log in. as this. You're going to use the use another account option if you're asked. And then once you're signed in, you may have to accept some terms and conditions. Just click yes, accept. Once you get back to the main console, you'll see this is what I like to call the hamburger menu. You can click there and then search for BigQuery. Alternatively, you can also go to the search on the top, and let me switch to my console here. So 2 ways to get a BigQuery. Hamburger menu here, and then go to BigQuery. Big data. Here we go, BigQuery. Or go to the top search box and type BigQuery. I usually go for the search box, it's much faster. Okay, so this is how you get to BigQuery. Once you're in the console, in the BigQuery console, you'll see some options here on the menu on the left. You'll see the query editor on the top right. And then at the bottom here, depending on what option you select, you'll see some additional content. So the first step in this lab is we're going to create a brand new data set. A data set is where we have all of our tables. You can have multiple data sets within a BigQuery instance. So here, so let me switch back here real quick. The first thing we're going to do is we're going to click on the Create Dataset button. Do make sure that your project ID is selected. I think for the quick labs, there will only be one project showing up in there. In my case, you will see several, but just make sure you select the one project that you were provisioned, the one up here. Okay, so you're going to click on, you're going to highlight the project, you're going to click on Create Dataset, and then you're going to give that dataset a name. The name is BQML_lab. Data location, just leave as default. All the other options, just leave as default, and then hit Create Dataset. So let's go through that. So on the left here, as I mentioned, you'll find your project name. Make sure you highlight it. Once it's highlighted, you'll notice I have some tables here. You probably won't have it, or data sets. You probably won't have any data sets. So just make sure your project name is highlighted, and then go to Create Dataset. And we're going to name it BQML_lab, I think. Yep. Everything else just leave as default, and then go ahead and create dataset. That's it. So once you go back in here in the main console, you expand your project name, you'll see there's a new dataset, BQML lab. And let's move on to the next step here. So make sure you do click that, check that box that you've completed this task, so that you get credit for it. All right. So this is where things get interesting. We're going to start creating a machine learning model using SQL code and BigQuery. The first step here is just copying this query into the query editor. You can see here on the top, there's a copy button. So you just click that, and that puts the code in here. So you just go ahead and paste it into the query window. I'm going to go real quick through this at a high level just to show you what it's doing. So right here, we're creating a new model. We're going to call the model sample model. It's inside our BQML lab data set. Now, BigQuery supports multiple types of machine learning algorithms. In this case, we're doing a logistic regression, which means we're trying to guess a value that can only have two possible options, yes or no. Then we're selecting the data we're going to use to train that model. And we're pulling data from a BigQuery public data set. So Ashar was talking about some of our public data sets. That is one of them. It's just some sample data from Google Analytics. And it's just pulling the table GA for Google Analytics sessions. Those are web sessions on a website. So that's what the query does. It's creating a model and then just using a data set from our public data set to build a model. So again, as I said, we're building a model that predicts whether a visitor on a website will make a transaction, will make a purchase. So we're looking at some features or columns in our data. The device operating system that the visitor is using, whether the device is a mobile device or not, the country, the visitor's country, and then the number of page views in that session. So we're building the model called sample model. We specified it's a binary logistic regression. And we're trying to fit this label field. That's going to tell us whether they did purchase or not. It's only one column we're interested in. That's our predictor. Now, you saw here that we're pulling data from our sample data set, but we're not pulling all of the data. We're restricting that data to only pull records collected from August 1st, 2016 through June 30th, 2017. So that's about a month or a year, sorry, of data. And then once we run this query, we're going to be creating that model in BigQuery. So let's go ahead and do that. Go here, hit run. And then we can see here on the left that our query is running. And it's telling us it's taking about 10 seconds so far to build that query. In this case, the result of this query is not going to be any records. It's actually going to be a model that we can then run to do inference or to predict the values on a different set of data. This is going to take some time. This is going to take a few seconds because it needs to do some pre-processing steps, then build a model, train that model with the data that we passed it. And then once the model is ready, we'll get a notification here from BigQuery. So while that runs, I'm going to go to the live chat, just check and see if there's any questions here. So it looks like Jose is having some problems with the site. But it finally reloaded. So, okay, good job, Jose. I don't see any specific questions on the lab, so we're going to keep going. So the query, as you see, is still running. It's in the process of training our model now. So it's fitting that model with that training data set that we passed it, basically the select from where. And we limited that to 100,000 records. So that's our training data set. And as you can see, this is done. We're done. We have a model. So going back to the instructions, we can call this task completed now. Now, this is optional, but we'll go through it real quick. So we can look at some of the model information on training statistics to see how accurate the model was based on the data that we used to fit it. And we see some really cool graphs, area under the curve, and other metrics that are good. So to see those metrics, go back to the BigQuery console. Make sure you have your project. Then select the BQML lab data set that we created. Then underneath it, you'll see your sample model that we just created with this query. We have some metadata down here on the model details, the name of the model, when it was created, the type of model, logistic regression, and some of the training options, number of iterations that we use to train the model, etc. But if we go here to training, we have some really valuable data, the learn rate, the number of iterations and how long each iteration took in the training of the model, the loss of the model as it progressed with the iterations. We can see this in raw form. So we can see that per iteration, some of the summarized results for these key metrics. So I'm just kind of taking a quick look at the chat here. It looks like a lot of people are having issues with Quick Labs. Hopefully not everyone is, but quite a few folks are saying they're having issues. So Brian, I'm sure you're checking in the back, making sure that Quick Labs is running well. We're gonna keep going. So once we build a model, we need to then evaluate that model and see how good it's actually fitting our data, right? How well it's doing those predictions. I know some of you are saying the model is still running, so I'll take it slow, but it should be relatively quickly. Okay, so evaluating the model, we're gonna basically copy this query and replace the query we had in BigQuery. Now what this query is gonna give us is it's gonna give us some metrics on the performance of the model. Mean absolute value, mean squared error, R2 score, as well as some other fields like precision, accuracy, area under the curve. All of these metrics, you can look in our glossary to understand what they mean. You might be trying to optimize your model or minimize the errors, the mean errors, or you might be more concerned about precision or accuracy. So depending on that, you might want to make some changes to your columns, your features, what we call feature engineering. So let's go back to BigQuery. We can actually click on Compose New Query, and that'll give us a brand new query editor. We're going to paste the evaluate query. Now notice this query looks similar to the one before. At least the select from where looks very similar. We're still pulling the same fields. We're trying to now evaluate the model, right, against a different data set. But we're doing ml.evaluate versus create. And we're just going to run this now. And this shouldn't take as long as the one before, but the one before was training the model. But this one's much quicker. Only 2.1 megabytes were processed. And here's where we have those results. So your precision, your recall, your accuracy. So 0.98 accuracy looks extremely well. This is the result that we got. So looks pretty well to me. We can go ahead and click or check the box for this task. All right. So we created the model, we trained it, then we validated it to make sure that it's actually predicting good data. And then we're going to use the model. So now we're actually going to use a completely separate data set where we don't know whether the customer made a purchase or not. and we're going to use our model to predict that. So now we're just going to copy this. It's going to give us the top 10 countries by purchases based on those predictions that the model is doing. So go back to BigQuery. We're going to compose a new query. And let's kind of go through it real quick. Again, as I said, we're selecting the top 10 countries, right, that have the top number of purchases. So that's where we're summing the predicted values as total predicted purchases. Now we're calling ml.predict versus ml.validate. So we're actually running a prediction against our model. We're passing the same fields for the data from our data set, sample GA sessions. But the result of this is going to be grouped by country, and it's going to be the top 10 countries only. So let's go ahead and run that. And you can see how fast it was. It took only 1.2 seconds. It was able to go through that data set and basically give us a prediction on purchases by country, sorted by the most number of purchases, and then all the way down to the least. So you can see United States had the most purchases for this specific example. So we saw the results down here. So just one thing to show you, this gives you a view of the results of your query. You can also see what that looks like in JSON. So if you're doing some programmatic programming, right, you're calling BigQuery from another application, you might be receiving your results in JSON format. There's some additional information here on your execution details. It actually tells you how long it took to do a read, to do a compute, to do a write. If you want to see how quickly the query ran. All right, so let's move on to the next step or the next task. We can click the completed task checkbox. Let me take a quick look at the chat, make sure that folks are making progress. Alan says you got different results, not big changes, but still a difference. And that's totally possible. We are using the same data set with the same training data set and validation data set, but there's obviously randomness in the system. So the results might not be exactly the same. And obviously do ask any questions you may have. All right, so the next step, we did a prediction by country. Now we're going to do a prediction per user. So we're going to be looking at a user ID. Obviously, this is GA data. It may or may not be anonymized. So we may or may not know who that user is, but it will have some user ID. So let's go ahead and copy the query. We'll go back to the BigQuery console, compose a new query. And let's go through it real quick. So it looks like this. In this case, we're just selecting the visitor ID. So when a visitor comes to the website using a tool like Google Analytics for web analytics, we're able to tell you which customer ID visited the website, how long did they stay there, how many pages they viewed. That's how we're able to predict. So we're looking at the visitor ID. So we're looking at individual people, and then we're trying to predict the total purchases per individual. The rest looks the same. We're basically doing a prediction with our model, sample model. We're passing this data set from our sample data set for GA sessions. And then we're grouping by visitor ID and ordering by, in descending order. So let's go ahead and run this query. And here we have the results. So we're only looking at the top 10. Visitor ID 941785, etc. Our model is able to predict that this one user might be the one that makes the most amount of purchases, 4 purchases. And then the rest have 2, all of them. All right, cool. So with that, you can check your task completed. And that's the end of the lab. I know we probably went a little fast. Hopefully you all were able to keep up. And for those having issues, technical issues, I believe Brian said you guys can try to run this, each one of these labs at least 5 times, I think. Okay, Jose, it looks like the website is back up. Awesome. Okay, so let's do some testing of our understanding here real quick. BigQuery is a fully managed enterprise data warehouse that enables super fast SQL queries. We didn't really go into that in detail, but that is true. BigQuery is a fully managed, meaning you don't have to provision any servers. As you saw here, you simply have a UI. You can create a data set. You can create some tables, load your data, and off you go. You can start writing queries. You can share your data set with other team members, and that's it. Super fast queries as well, leveraging the scale of Google infrastructure, the same infrastructure that runs YouTube, where this live stream is happening. The same infrastructure that runs search, that runs Gmail, is running this query for you. So that's how we're able to run those queries extremely fast. So I'm going to say true. Well, I can't select it because I'm not running the lab. And then you can access BigQuery using, I think this is the same question we had in the last lab. We know there's a REST API. I said that in the chat. We also have the web UI. That's what we've been using in this lab. And then we have a command line tool, or CLI, command line interface. That's the BQ that we used in lab number 1. You can install that on any computer, or you can run that directly from our Cloud Shell that runs within our console. All right, so that is the end for lab number 2. I'm going to pause here for a second, a quick minute. I'm going to go back to the chat and see if there's any outstanding questions. Okay. So I see a few folks having some connection issues. Hopefully you'll be able to watch the recording again and run through the labs at a later time. Prakash is asking for the link to the crash course. Give me 1 sec. There you go, Prakash. So Chris says, I think it's safe to say that everything we've done in Lab 2 with Web UI can be done using CLI, using appropriate commands. Absolutely, yes. There's multiple ways to do it: through the CLI within Cloud Shell, through the CLI from your local computer, laptop, or if you're doing a programmatic type use case where you have not a human, but an application or some system run a query, you can do that through a client library like an SDK. And we have those available for multiple languages. Okay, so Let's go ahead and switch to the next lab. So I'll give everyone a minute to go back to the main menu in Quick Labs and select the next lab, which is weather data in BigQuery. Okay. So we'll go through the overview again. I think you get the drill now. With Quick Labs, we're going to run Quick Labs in incognito mode. Now, this data, this lab, what we're doing here is we're moving away from BigQuery ML, and we're going to look just at BigQuery as a data warehouse or data intelligence platform. And we're going to leverage some of our public data sets in BigQuery. We're going to look at the NOAA weather data and the citizen complaints data from the New York City, or from New York City. Here we talk about some of the features of BigQuery. I mentioned it's serverless, it's easy to use. It can scale extremely fast. So it's perfect for big data analysis where you have really large data sets. And then shareability, I mentioned, once you create a data set, you can easily share it to anyone else that has a Google account, and they'll be able to log in directly to BigQuery console and then start writing SQL. All right. So in this example, in this lab, we're going to look at correlation with some weather patterns. So, and how or whether there is a correlation with complaints and weather patterns. So first, we're going to start with the setup. Again, every time you go to a lab, you're starting a brand new session. So make sure that when you finish lab number 2, you click the End Lab button. And then once you get to lab number 3, you start the lab again as a new lab. That will provision you with a brand new console access, which will show up here. So we're going to follow the same steps. We're going to open the console. We're going to log in with the provided username and password. If you are asked, you're going to select the use another account. We're not going to select the previous account that we used for lab 1 or 2. You may be asked to accept our terms of service. Just click OK or accept, and then off you go. So again, we're going to explore some data within BigQuery. We know how to get to BigQuery. Remember, you can go to the hamburger menu, and then under Big Data is BigQuery. Or you can go to the search box, search for it. So let me just go over it again. Let me go to the home. Close this. So when you log in, you'll get to this view. Go to the navigation menu or the hamburger menu. Scroll down to Big Data, and then look for BigQuery. Or go to the search and type BigQuery. Okay. So we're in our BigQuery console. The first step in this lab is we're going to add a new data source. Now, this is different than before. We haven't done this yet. We talked about a bunch about these public data sets, but how do you get there? You need to click Add Data and then Explore Public Data Sets. Now, I have the public data sets here already, but we're going to pretend that that's not there. So we're going to click Add Data, Explore Public Data Sets. This is going to open a separate window from our Google Cloud Marketplace. And we can search for NOAA, NOAA GSOD, Global Surface summary of the day weather data. So I'm just going to copy NOAA underscore GSOD, hit enter. And that takes us to our data set, our public data set. Once you select it, that will add, or sorry, once you hit view data set, that will take us back to our BigQuery console, and it'll show us that table within our public data set. Okay, here it is. So what it actually does is it actually just adds this whole data source from the BigQuery public data project. So we have access to all these data sets. Right now, we're only going to focus on the NOAA GSOD. And if we expand that, we see there are several tables within it. So we did that. We hit view data set. We got the BigQuery console to open in a new tab. And then we saw that we now have the BigQuery public data in the console. We're going to go ahead and expand NOAA GSOD and then look for GSOD 2014. That stands for the year 2014. So we're going to look at 2014 weather data. We have data starting from 1929. So let's scroll all the way down and up to 2020. So let's select 2014. We can see the whole table schema here. So all the fields, the data types, and a short description of each. So if you want to know what STN means, it's station number. I think these you can tell their year, month, and date, temperature, number of observations, etc. So you can go through that on your own. Now, if we want to look at the table, at the actual data, the rows and columns, we can click the preview button in BigQuery. So over here, we have a preview tab. This is good. This is the same thing as doing a select star. It's just showing us all the fields, all the columns, and all the rows. It's showing us 100 records, but then you can go and explore the rest of the data by just moving from page 1 to the next page. So these are all the rows. These are all the columns. Like I said, if you don't know what STN means, what that column is, you can go back to the schema and look at the description for it. So that's how you preview data in BigQuery. So you can go ahead and examine those columns and some of the data values on your own. And once you're done with that, we're going to go ahead and copy this query in the text editor. So we'll go through it in a minute to see what it does. So go back to the BigQuery console. If you still have any left code from the previous example, you can click Compose New Query. I think it'll be empty for everyone since we switched projects. All right, so we pasted the query. Let's take a look and see what it's doing. So it's creating a timestamp from the date components. So it's creating a timestamp here. And then it's looking at some average temperatures and wind speed and precipitation from this data set. And it's actually restricting the data for anything greater than 2010. And it's looking at just one date, apparently June 12th. And it's looking at 2 locations, LaGuardia and JFK Airport in New York. And then it's just grouping and ordering. So let's go ahead and run the query. We processed 3 gigabytes of data. That's a very large data set, 3 gigabytes compared to what we were looking at before. Now, it's not huge. I've seen much larger data sets, but we were able to process 3 gigabytes in just 1.6 seconds. So that kind of tells you how fast BigQuery can be. All right, so we have the result of our query. We have basically for every June 12th, we have an average, and this is for two locations. That's why there's 2 records each. So for LaGuardia and JFK, we have the average temperature for that day, the average wind speed, and precipitation. Really cool. So you can check the box here. Now we're going to explore a different data set, the New York citizen complaints data. We already have our BigQuery public data project pinned to our console. So we just have to search for the New York data set and the 311 service requests table. We're going to preview the data, just kind of examine the rows and columns. And then we're going to run this query. And we'll take a look at the query and see what it does. So let's go to BigQuery. We're going to look for New York. And it is New York and then 311 services. Okay, so New York, 311 service requests. Yep. So now we're going to compose a new query. Oh, let's take a look real quick at the schema. So we have, this is our service request. So there's a created and closure date, an agency, a complaint type, etc. The preview here shows us the actual raw data. So these are some of the fields, rows and columns in that data set, some of the service requests. So now let's paste the query. Let's take a look real quick and see what it's doing. It's selecting a year. It's looking at complaint types and doing a count per year. Okay, and also looking at complaint type as a category. So for every year, the complaint type that has the most complaints is what we're looking at. So there's a lot of noise complaints in New York in 2017. Interesting. Okay. So once you do that, you can click check the box, move on to the next. Now, one of the cool things about BigQuery is that you can create a new table using the results of a query that you run. That's what we're going to do next. We're first going to create a new data set, and we're going to call it demos. So we haven't done that yet. We need to first select our project name and then create data set. No, I think we did do this. All right, we're going to call it demos. Leave everything as default and then create. All right, here's our new data set. No tables in it yet. All right. Check the box. Now we're going to compose this query. But before we run the query, we're going to make some changes to our query so that the results of this query are stored in another table that we can then use to query more. We're going to call that table New York City weather, and we're going to allow it to store any size of results. So let's go ahead and do that. We're going to compose a new query. We'll take real quick a look at what it's doing. So it's also creating a timestamp, and it's doing a bunch of averages. Average temperature, visibility, wind speed, etc., etc. We're going to run this from the 2 airports we looked at. But before we run, we're going to go to more, query settings. We're going to go to destination and set a destination table for the query results. Make sure your project name is selected, and then you select the demos data set that we just created. And we're going to allow large results. We're going to have to give it a name for the table, that is. So the table name is New York City weather. Okay, everything else you can leave default and then hit save. Okay, so after we do that, we hit run. And that's going to run our query. Notice at the bottom here of our query window, we now have a label that says destination table and then New York City weather. This is telling us that once I run this query, the results are going to be stored in that table. It's going to write if the table is empty, and it's going to allow large results. So we're going to go ahead and hit run. We processed 4.7 gigabytes of data in just 2.5 seconds, so extremely fast. And we see the results here, but we also notice there's a new table down here under demos. And if we go to preview, we see the same results. So those are the results of our query. That's it. So we see demos and then our table. We can go and select it. Now we can go back to more query settings and change the destination field to only create a temporary table. That way you're only storing those results temporarily for that session. So we can do that. Query settings, and then just switch this back to temporary. And once you do that, then it disables the table name and all the other options. And then we run this once again. This time it didn't update the table, New York City weather, it just gave us the results here in the console. The query was 0.5 seconds faster, probably because there was some caching. We had run the same exact query before. And then we're ready to start finding correlations. So we're going to copy this function or this query. This query is using the correlation function. So it's actually looking at temperature and average count of complaints to see if there's any correlation with those two data sets. Very interesting. So go ahead and click compose new query, paste the contents of a query. This one's a little longer, so we're basically selecting the sum of complaints, count on temperature as data count, and then we're going to round the result of our correlation function, looking at temperature versus average count and average PCT count. I think that's a complaint count. We have some query nesting here, so we're doing some selecting here again, another selecting here. So this is a more complicated query. I'm not going to go into detail. You can look at it later, but it's just doing some joins. It's doing some query nesting. We're going to go ahead and hit that run, and then we'll see the results of our correlation analysis. All right, here we go. So for each description type of complaint, we have the total number of complaints, the total data counts, that's the number, the total counts of temperatures, and then based on those two, it's giving us a correlation value. So the results indicate that heating complaints are negatively correlated with temperature, more heating calls on cold days, and calls about dead trees are positively correlated with temperature. Interesting. So we can see that in here, a negative correlation here. And then the tree has a positive correlation. So that checks out. Now we can look at the same thing, but instead of looking at temperature, we're going to look at the wind speed. So we copy the query. This time I'm not going to go through it. I'm just going to paste it and run it. And here's the results. Here's the correlation for each type of complaint. And here we notice that both correlation columns are negative for noise-related complaints. So I'll leave some homework. You can think about what's your hypothesis for why noise complaints reduce on windy days. Interesting. That is the end of the third lab. So I hope you guys were able to follow through. I'm looking at the chat here real quick before I pass it over to our next speaker. But I see, Sam, you had some issues with the New York City weather table. I would check the query options again, make sure that you selected the destination table for query results and that you gave it a name. All right. That is all I had for you. Now, there is a fourth lab that I encourage everyone to go through. That one's a little longer. It says it takes about an hour. I know I flew through these, but they usually take much longer. And hopefully you guys are going through each step and trying to understand what's happening. So yes, so you'll have access to the labs to finish the full 4 labs. And with that, Asar is going to go back on stage with us.
Hi everyone. Let me share my screen. Give me a second. Yes. So thank you all so much for coming to this event. I'm the Developer Student Club lead at FIU, wherein we'll be starting to host a whole bunch of events starting next week. One of them being our info session on next Wednesday, where you'll be able to get to know more about us, and some other events happening later on the week, such as a Flutter workshop and an Intro to Web Development workshop. So make sure to definitely sign up for our Instagram, join our website, or check out our website at sites.google.com/viewed/DSCFIU, and also to get in touch with members in the community. Make sure to join our Discord server using that link. And yes, this was such a great event. So thank you all so much for coming. Thank you all so much.
Thank you everyone for joining in our Cloud Hero workshop. We will definitely drop the recording of this workshop into the ShellHacks Discord tomorrow after opening ceremony. So definitely stay tuned with that. And also as well, once you complete all the 4 labs and you guys sign in with the sign-in sheet that was dropped into the chat, we can definitely drop it in one more time. Once you sign in and complete all the 4 labs, stay tuned. We do have a raffle coming up after the hackathon. I just want to give a huge shout out to Gustavo. Thank you for walking us through labs 2 and 3, and also being here super late. I know you guys are both on the East Coast, while me and my colleagues are here on the Central Standard Time. So it's not too late for us. But yeah, thank you everyone. And yeah, have a great night, everyone.
Thank you so much, everyone. Have a good night.
Bye.
Bye, everyone.